In this video, I'll show you how to solve application problems containing quadratics. This is question 2. The question asks, a rock is thrown off a cliff. Its height in meters after t seconds is modeled by the function h of t is equal to negative 4.9 t to the power of 2 plus 10t plus 17. Part A asks us, how high is the cliff? Now, since the rock is being thrown off a cliff, and that h, which represents height, is the dependent variable, essentially this is our y, we can model this like so, where we have t as our x, which represents time, h as our y, which represents height, and the rock is being thrown off a cliff. So presumably it is being thrown at some height, and it is taking on a parabolic trajectory. So it's going like this. And for part A, they're asking us how high is the cliff? Technically, they are looking for the coordinates at this point right here. Now we know that the second the rock is thrown, the time begins. So before the rock is thrown, the time has to be at 0. Therefore, the x-coordinate of this point has to be 0. Once we find the y-coordinate, we have solved A. So what we can do is take this x-coordinate, or in our case, this t-coordinate of 0, and substitute it into our equation to find out the height. So let's do that. H at 0, or time 0, is equal to negative 4.9 times 0 to the power of 2, this goes to nothing, plus 10 times 0, and this also goes to nothing, plus 17. Therefore, we can say that before the rock is thrown, the rock is being thrown from a height of 17 meters. Let's move on to question B. In question B, they ask, what is the height of the rock after 3 seconds? Now they want us to find out the height after 3 seconds. And obviously, it's going to be less than 17 because 17 is its starting point. What we have to do for B is substitute 3 into our formula. Putting this into our calculator, we end up with negative 4.9 bracket 3 to the power of 2. So 3 to the power of 2 times negative 4.9 plus 10 times 3 plus 17. And this gives us 2.9. So what this means, and this means that the rock is falling really quickly, that within 3 seconds, it has reached almost a height of 0, technically, 2.9 versus what we started off with at 17. So let's say that this over here represents t is equal to 3, and this would represent 3 and 2.9. Finally, in question C, they ask, when does the rock hit the ground? So this time, they want us to find out what the t value is when h is equal to 0. Now, this is the hardest part of the question, and here's how you would tackle it. The first thing that you would have to do is set the whole equation equal to 0. So let's go ahead and do that. So for C, we want to find out when h is 0. Negative 4.9 t to the power of 2 plus 10t plus 17. Now, in order for us to find out what t is, we need to do one of two things. Either A, we use the quadratic formula to find out what our t value is, or B, try to factor this out. Now, given my experience with factoring quadratics, usually when your a term is a decimal, that means you can't factor it easily. So it's best to do the quadratic formula from the get-go. So let's do that. 0 is equal to, and by the way, this is our a term, so a is equal to negative 4.9. This is equal to b as 10, and our c is equal to 17. And remember, the quadratic formula looks like this. We're going to plug in these values into our equation. We end up with negative 10 plus minus the square root of 100. I've already applied this 10 into my b. 10 to the power of 2 is 100, minus 4 times negative 4.9 times 17. All over 2 times negative 4.9. Now that I've set up my quadratic equation, instead of going through this manually, what I'll do is use the function on my calculator just to speed the process up a little bit. and my A was negative 4.9, my B was 10, and my C was 17. This function does the quadratic formula instantly. So I'm going to take these values where my first t is equal to 3.14 seconds. That's my first t, and my second t is equal to negative 1.10. So had you done this using the quadratic formula, you should have gotten these two numbers. Now, which one of these is correct? We can scratch this one off right away because you know you can't have negative seconds in this situation. Therefore, what makes sense in our particular scenario is that after 3.14 seconds, the rock will have hit the ground, giving us a height of 0. And so there you have it. That is how to solve application problems containing quadratics. If you found this tutorial helpful, please support our channel by subscribing or by liking this video. If you have any further questions, visit our website at studyforce.com. We're an online service for students seeking free homework help. See you soon.